Okay, here we're looking at section 7.7. So our learning targets for this section are to factor the difference of two squares, then we're going to be factoring perfect square trinomials, and then thirdly we're going to be using factoring to solve real-life problems. So let's look at our first pattern we're going to be looking at. So this is called the difference of two squares. So when I see I have two things that are being subtracted, right, we're talking difference, and difference means subtraction. If I have two things that I know the square root of, this is the difference of two squares. So if I see I have a squared minus b squared, I can factor that into a plus b times a minus c. So here's the example. If I have x squared minus 9, well, I know, first of all, we're subtracting. So then I know the square root of x squared and I know the square root of 9. So this can also be written as x squared minus 3 squared. So then I can just follow my pattern. It would be x plus 3 times x minus 3. So then from here I could solve and find my two solutions. So let's go ahead and try this. So for this first part, factoring x squared minus 25. So I see that it's subtracting, and I know the square root of x squared, and I know the square root of 25, so I'm going to go ahead and rewrite this. It's going to be x squared minus 5 squared. So I know that I can follow my pattern with, one's going to be a plus, and one's going to be a minus. So I'm going to have x to start with, because x is the square root of x squared. And then 5 is going to be the second term in both of those because 5 is the square root of 25. So now I'm done with that one. So let's look at b. I have 4z squared minus 1. Again, I notice I'm subtracting. I know the square root of this first term and I know the square root of the second term, so I can go ahead and figure that out. So I know my first term is going to be 2z, the quantity 2z squared, minus 1 squared. Right? Because I know that 2z, the quantity 2z squared, is the same thing as 4z squared. So now that I have it written like this, I can go ahead and write my product of two binomials. One's going to be a plus, one's going to be a minus. The 2z goes in the first spot, and the 1 goes in the second spot. So now I've factored these completely. So now we can use this pattern to evaluate this expression, right? So I've got 54 squared minus 48 squared. So let's see what we can do. So it is a difference of two squares again, right? Because I've got something squared and something else squared. So I can rewrite the expression as 54 plus 48 times 54 minus 48, which is that same pattern. Right? I take the square root of the first term plus the square root of the second term times the square root of the first term minus the square root of the second term. So I just rewrite that as my pattern, and then I simplify. So I know that 54 plus 108 plus 48 is 102, and 54 minus 48 is 6. So now this is some multiplication that I can actually do pretty simply. So I can go ahead and multiply those out. So 54 squared minus 48 squared is 612. This can be much easier than trying to figure out what 54 times 54 is and what 48 times 48 is, and then subtracting those two. So I can use my same patterns if I'm just dealing with numbers as well. So here are a couple I want you to try, see how you do. So now here's our second learning target, our perfect square trinomials, right? And remember, tri meaning 3. So I see that if I have something squared at the beginning and something squared at the end, and I've got this 2ab, I can then factor it to this. Remember, several sections ago we worked this way. If you were given this term right here and told to expand it, this is what we ended up with. And same down here. We were given several of these and we worked backwards. Well, now we're going to be going this direction. We're going to be working kind of the opposite way that we've been doing. And we want to be able to do this because we're going to be factoring and we're going to continue to be solving for different quadratics, and that's what we're doing. So let's go ahead and look at a couple of examples. So I see here I've got something squared, and I know the square root of this last term, and I also see that this middle term is 2 times the square root of this last term, right? So I know that I'm going to end up with n plus 4 squared. So if I don't remember this, can I do it the long way, the way that we've been looking at? Let's try it. Right? So I want to find all of my possible factors of 16, a positive 16. So I've got 1 times 16, or I've got 2 times 8, or I've got 4 times 4. So now let's find the addition, the sum, right? I add them together and see what I get. So 16 plus 1 is 17, 8 plus 2 is 10, 4 plus 4 is 8. So I'd see I would be using this grouping right here, right? Because it added up to the middle term. So then I could rewrite it, right? I would have n plus 4 times n plus 4. Well, since these two things are the same, I can write them as n plus 4 squared, right? So it works out the same. Even if I don't recognize the pattern, I can still follow the things that I've done and it will still work there. So let's look at this as well. So I know I've got something x squared, so I know the square root of this and I know the square root of this, right? So I could do it this the long way. So when we start to get here, we end up with things going the very long way. But I notice the pattern. If I know the square root of the first term and the square root of the last term, and this would be 2 times those two multiplied together, then I know I'm in a good spot. So now I can follow my pattern, and I see that this is a subtraction sign, so this will also be a subtraction sign. So the square root of this last term is 3, and the square root of the first term is 2x. So I could do this the long way again. I'm not going to show you that, but I could. It just takes a lot longer than recognizing the pattern. And I can always go back and double check my work, right? So I've got 2x minus 3 times 2x minus 3. Be careful when we have this squared sign that you don't just do like 4x squared minus 9. Those are very different things. So now let's try this. So I've got 2x times the quantity 2x minus 3 minus 3 times the quantity 2x minus 3. Let's try it. 2x times 2x is 4x squared. 2x times a negative 3 is negative 6x. Negative 3 times 2x is negative 6x. Negative 3 times negative 3 is a positive 9. So then these two middle terms combine to our negative 12x. So I notice here that I end up with the same thing that I started with, so I know my factoring was correct. Okay, so now here's an example using fractions, right? And I know many of you don't like fractions, but we still use it the same way. So I could go through and multiply everything by 9, and then I have whole numbers, but then I have some really funky stuff to deal with. Then I end up with a big number here in front of my x squared term. But it can be done that way. So let's go ahead and solve it that way. This one can be solved several different ways. If you love fractions, you can notice that you do know the square root of this fraction, right? 1/3 times 1/3 gives me this 1/9. So I could just follow my pattern this way, but the first thing we really kind of want to do is multiply everything by 9, right? So if I multiply everything by 9 on every side, I end up with 9x squared plus, and these kind of cancel out, 6x plus 1 equals 0. So again, I can see I know the square root of my first term and I know the square root of my last term, so let's go ahead and write it out. This is a plus, so it's going to be a plus in here. I'm going to end up with 3x plus 1 squared. So we can try it out, right? 3x plus 1 times 3x plus 1. Let's see what we end up with. So 3x times the quantity 3x plus 1 times the quantity 3x plus 1. Let's see where we go. So 3x times 3x is 9x squared. 3x times 1 is 3x. 1 times 3x is 3x. 1 times 1 is 1. And if I combine these two middle terms, I end up with 6x, which is what I started with, so I know that my factoring was correct. So if you're given fractions, you can first get rid of the denominators and try and deal with just whole numbers. So the reason we picked 9 here to multiply all of my terms by, because that's the lowest common denominator, right? I could multiply everything times 27, right? Multiply all of my denominators together and use that, but that'll just make more things that I have to factor out in the long run. So here are some for you to try. Really look here down at this number 13, because we're dealing with fractions, and I know that fractions can be difficult, so the more you practice, the easier they will be. So now let's look at kind of our word problem, and this is our real life problems. This is our third learning target for the day. So a bird picks up a golf ball and drops it while flying. The function represents the height y in feet of the golf ball t seconds after it is dropped. The ball hits the top of a 32-foot tall pine tree. After how many seconds does the ball hit the tree? So there are many steps we want to do, right? And when you're taking notes on this, don't write all of this out. This is not useful information for you to have. We want to figure out what we're going to actually use. So I know I'm given the height of the golf ball as a function, and I'm given the height of the tree. Okay, so then I have to figure out how many seconds it takes. So I want to use the function for the height of the golf ball and substitute. So I want to substitute 32 for y and then solve for my t, right? So one thing that we've missed that was not included in this screenshot is in your book and in the example you were given the function. You were given that y equals 81 minus 16t squared, right? So we were given the function. That's where I just got stuck for just a second. So we were given the function, and now we were told some heights. So first thing I want to do is I want to substitute that 32 for y and solve for my t. That's the first step I want to do when I'm given the height of the tree. Okay, so I substitute my 32, then I subtract 32 from each side. And I notice, oh, I know the square root of this first term, and I know the square root of this second term, and I see I'm subtracting, so this I know I'm going to be using the difference of two squares. So I can rewrite this as the square root of the first one squared minus the square root of the second one squared, and then rewrite it out as my difference of two squares pattern. Then, using my zero product property, remember I set each piece equal to 0, and then solve for t. So here are my two possibilities. So t is either a negative 7/4 or a positive 7/4. So now I want to think back, what does t stand for? T stands for time, right? T seconds. So looking down at these two answers, this first one doesn't make sense because I cannot have a negative time. I only want to have a positive time, so I know this is going to be my answer, right? So the golf ball hits the tree after 7/4 or 1.75 seconds. Okay, so now I can look back and I check my solution. So if I go ahead and put this fraction back into my original equation, then I can verify that it does in fact equal 32. So here's just the checking of what we were doing. So all we really did was we figured out, we were given this equation. This is not something you're going to have to come up with, and we have to figure out how long it takes for the ball to hit the tree. So I know what the y value is, and I substitute that and see what I get. So try this one. What if the ball does not hit the tree? After how many seconds does it hit the ground? So the first thing you have to do for this is figure out what your y value is when the ball hits the ground. And then from there you can figure out how long it takes. So let's look back at our learning targets for the day. First one was factoring the difference of two squares, right? And we saw that pattern on this page. This is my difference of two squares pattern. The first thing we always have to realize is we're subtracting, and we know that the square root of the first term and the square root of the second term. So once we have those things, we know we're looking at the difference of two squares. Our second learning target was factoring perfect square trinomials. Now we did this several times in the last several sections, but we were going the other direction. We were expanding, so now we're factoring and going the other way. And then we can use factoring to solve real-life problems. We're going to be doing this one often, so we want to look for these different patterns when we have those real-life word problems. So now that we've done this and looked through some examples, go ahead and start working on the homework for 7.7.